students, in previous classes I shown you how to find the electric field intensity due to infinitely long charge wire. Today I am going to show you how to find the electric field intensity due to uniformly charged ring. Actually, we want to find out the electric field due to this charge ring at the point P. P is the point where we want to find the electric field due to the charge ring. Now see, this point is located at distance x from the center of the ring. Now in order to find the electric field due to the charge ring, we need to know that what is the charge density of the ring. So first of all, we want to find the charge density of the ring. So because the charge q is distributed to the entire circumference, so the charge density of the ring lambda is equal to q by 2 pi a, because you can see that the radius of the ring is a. So lambda is equal to q by 2 pi a. Now in order to find the electric field at the point P due to this ring, we need to select an element dl. And because of that, I have selected an element dl here. After selecting the element dl, I should find the value of charge on it. And for that, I actually used my concepts that charge on element dl is dq is equal to lambda into dl. So what is the value of lambda? Lambda is equal to q by 2 pi a. So q by 2 pi a into dl. So finally we got the value of charge. So this is equation number 1. After getting the value of charge on the element dl, I can find the electric field at the point P. And for this purpose, I need to know the distance between the charge dq and the point P. And you can see that the distance between the charge element dl and the point P is r. R equal to root over of a square plus x square. So electric field at the point P due to this element dl. So electric field at P due to element dl is dE is equal to 1 by 4 pi epsilon naught dq by distance is r, so r square. Now because it is a vector quantity, so it should have a direction. So because the charge is positive, it should act outward. So it is acting along PC. So acting along PC. Now you can see that the direction of the electric field or the electric field makes an angle theta with the x-axis. So when a vector quantity makes an angle with any direction, we can take the components. So if I take the components of the electric field dE along this direction, the component will be dE cos theta. And along the perpendicular direction, it will be dE sin theta. Clear? Now, I can take another element dl here or dl dashed here. For the element dl dashed, the electric field produced at the point P will be same and it is denoted as d dashed. Clearly you can see that the angle also made by this electric field also theta with the x-axis. So because both the electric field d and d dashed are equivalent to each other, I can take the components of the electric field d dash now. So you can see that along the direction, along the x-axis, the components of the electric field is d dash cos theta, and along this direction, that is dE dashed sin theta. As the magnitude of dE and d dashed are equal, So we can write that both the components like dE dash sine theta and d sine theta, they're acting on the same line and they are equal and opposite. Because of that, they will cancel each other. So as dE and dE dash are equal, so the sine, so the dE dash sine theta and dE sine theta cancel each other. So this is a very important point. We need to remind this, that because both the electric field produced by the element dl and dl dash are d and d dash respectively. What we have, this d and d dash are equal. So when you find the components of the electric field of d and d dash, you can see that d dash sine theta and d sine theta are acting on the same line. They are opposite and equal, so they cancel each other. So along the x-axis we have the components of the electric field, and that is d sine theta. So by getting integrated of the components d cos theta, we can have the total electric field produced by this uniform charge ring. So the total electric field at P due to the charge ring E is equal to integration of dE cos theta, total ring. Now put the value of d here. What is the value of d? D is equal to 1 by 4 pi epsilon naught dq by r square into cos theta, total ring. Now we have to find out the value of cos theta. From this triangle we can find the value of cos theta. So what is the value of cos theta? The value of cos theta is dq by r square. Acha, just put the value of dq. dq is equal to what we have, q by 2 pi a into dl, q by 2 pi a into dl, and the value of cos theta is, you can see that, x by r. Sorry. X by r. Okay. Now, what have to do? Because the variable part is dl and all the elements are situated on the circumference, so the limit of integration should be 0 to 2 pi a. Taking all the constant out of the integration, we have qx by 4 pi epsilon naught, we have r cube here and 2 pi a, by integration of the term dl, we have qx by 4 pi epsilon naught r cube 2 pi a. Now what is the integration of term dl? That is, dl means 2 pi a. So 2 pi a and 2 pi a cancel out. So finally we have the electric field E, and that is E is equal to, just write down, qx by, now 4 pi epsilon naught, this is r cube, means r equal to a square plus x square, because R cube is over there, so it should be 3 by 2. So finally we have electric field E is equal to Qx by 4 pi epsilon naught A square plus x square to the power 3 by 2. So we got the electric field, total electric field due to this uniformly charged ring. Now there are some cases. First of all, I want to find the electric field at the center of the ring. So what we need to do, just write down at the center, case 1. At the center or at center, what we have, x equal to 0. Okay, so if x equal to 0, then what we have, the value, the electric field must be equal to 0. So electric field inside the uniformly charged ring is equal to 0. At the center, the electric field is 0. So how we get this? Just put the value that x equal to 0, you will get that electric field equal to 0. Okay, so once again, I want to remind you that whenever you want to find the electric field due to the uniformly charged ring, so you need to find out the charge on an element. Okay, that means you have to consider element dl and find the charge on the element dl. After getting the charge, you measure the distance of the points where you want to find the electric field. Let it be r. After getting the distance of the element and the points of applications, you just write that electric field due to this element dl is equal to 1 by 4 pi epsilon naught dq by r square. As because it is a vector quantity, so it should have a direction. So you can see that because the charge is positive and for positive charge electric field acting outward, so it is acting along the direction PC. Acha. Now I also taken another element dl dashed. Okay. So dl dashed actually produced an electric field de dashed here, and this d dashed and de actually equivalent to each other. So getting all the components of d and d dashed, we actually have that the d dash sine theta and d sine theta actually cancel each other, and finally what we have along the px direction, we have the electric field, total electric field because of this ring is de cos theta. So if you want to find out the total electric field, you need to integrate the equation. That is why I have E is equal to integration of de cos theta total ring. Now after getting all the values, we have this one. So because the elements actually stayed here on the circumference, that is why the limit of integration must be 0 to 2 pi a. So after having all this equation and calculation, we have the electric field E is equal to Qx by 4 pi epsilon naught a square plus x square to the power 3 by 2. Now, there's some question that what is the value of the electric field at the center? You can see if I put the value of x equal to 0 here, you will get that E equal to 0. So, at the center of the ring, electric field is equal to 0. Now, if you want to find out the electric field at the point P or on the surface of the ring, what will happen? So, on the surface, case number 2, on the surface you can see that key x equal to a. Just put the value of x here, that is equivalent to a, you will get the value. So E is equal to what we have, the equation is qa. So just write down the equation. E is equal to qx by 4 pi epsilon naught a square plus x square to the power 3 by 2. Now put the value x equal to a. So this is equal to qa and this is 4 pi epsilon naught a square plus. Now x equal to a, so a square 3 by 2. Now qa by qa by 4 pi epsilon naught, this is 2a square. So 2a square to the power 3 by 2. So what will be? It will be 4 pi epsilon naught. So square square cancel out, so it will be 2a to the power q. So qa by 4 pi epsilon naught 6a cube. So qa by, now this a and a cancel out, so q by 24 pi epsilon naught a square. So we finally got the value of the electric field on the surface, and that is equal to q by 24 pi epsilon naught a square. Now I want to find the value of the electric field far away from the center. Okay, far away from the center. Case number 3. So when the point is far away from the center, then when P is far away from the ring, then x square is greater than a square, because we know that the point is far away from the center. Therefore the central distance x, that means the distance of point P and O, is x. So this is greater than the radius of the circle or ring. So x square greater than a square. So we can neglect the radius of the circle. So from the following equation, what we have, E is equal to, we have qx by 4 pi epsilon naught. So we can neglect a square here. Okay. So after neglecting a square, we have x square to the power 3 by 2. So this is qx by 4 pi epsilon naught. This must be q. Now this x and x cancel out. So finally we have q by 4 pi epsilon naught x square. So we got the value of the electric field at the center, on the surface, and far point or far away from the charge ring. So by this way, we can easily find out the electric field due to this charge ring. Thank you.